Number 8, decide whether the pair of functions graphed are inverses. So this is very similar to number 7. Again, we're being asked to determine if our two functions that are provided are inverses. So again, for the sake of number 8, let's go ahead and let this top solid line here be our f function. We will let this bottom solid line be our g function, and the dotted or dashed line cutting the graph in half here is the line y equals x. All right, now we talked about in number 7 how oftentimes you'll hear the y equals x line referred to as a mirror, and what that means is, does the f of x function, does the f function reflect over the y equals x line to become the g of x line? And I talked about in number 7 how people who are visual oftentimes don't have any problems seeing that in their mind, but I'm not quite so visual, so what I like to do is find 2 or 3 points on the f function and see if I can find the reverse of those points on the g of x function. And I think that's what we're going to do here as well. So our first point that we can clearly see on the f of x function is the y-intercept here, and this is the point 0, 3. So if the g function is going to be the inverse of the f of x function, then we would expect to find the point 3, 0. All right, well, let's see. The point 3, 0 is right here, but we can clearly see that the g of x function is not going through this point, and so right away we can stop and say that no, f of x and g of x are not inverses. All right, again, what inverses really mean are that the domain of your f function, the x's from the f function, become the y's of the g function, and the y's of the f function become the x's for the g function. So your domain and range are swapping. All right, so 0, 3, that point is on the f of x line. In order for g of x to be the inverse of f of x, then the point 3, 0 needs to be on g, but we can see that it's not, and so right away we don't even have to test any more points because the domain and range flipping has to be true for every single point. As soon as you find a single point that fails or that's not true, then you can stop and the two functions are simply not inverses. And so there we have it. Number 8, not inverse.